Hi, welcome to the session CSV to Parquet, Managing Data for Multi-Language Analytics Teams. This is Viswadutt Poduri. So the aim of the session is to introduce Parquet format and give a practitioner's perspective on how one should change their workflows around this format. And we want to focus on what can be done immediately to improve speed in your current workflow and optimize the cost. We won't be getting into the details of software engineering behind the format or the implementation details. So let's talk a bit about the CSV files and why one should move from the CSV format. So CSV often comes to mind when sharing or storing data. This is a simple file format which is a flat file that stores the tabular data using separated by commas, and the new records are separated by new lines. This is simple and lightweight, and you do not need any additional installation to read or write CSV file generally, and it allows the users to open and inspect the data, which is a very useful property sometimes, and this is perfect for small data sets or one-off use cases, and this is supported by both R and Python and any other analytics tools as well. And spreadsheet programs like Google Sheets, MS Excel, OpenOffice all support CSV natively. But let's look at some of the drawbacks that these files have. These So CSV files cannot hold complex structure. If you have a rich data which has maps or arrays or geospatial data, it is very difficult to use CSV files. And if you have a data which is very large, but only you're interested in some small part of the data for your current analysis, then the CSV files are suboptimal, as you need to completely read the data and then get to the data where you need. So this is a suboptimal thing to do, and there is no schema in the CSV files. So you have to infer the schema as you read the CSV files, and this might introduce errors as you process down the line in your workflow. Let's look at Apache Parquet format. Apache Parquet is an open source column oriented data file format designed for efficient data storage and retrieval. It provides high performance compression and encoding schemes to handle complex data in bulk and is supported in many programming languages and analytics tools. So let's unpack this a bit and look at some of the features of the Apache Parquet format. So the Apache Parquet format can store complex and rich data such as arrays, maps, or geospatial data, and it uses columnar storage, making it easy to just read the required data instead of the complete file processing. So if you're only interested in a certain columns of the data, you can only read those columns instead of reading the complete file. And it stores the schema and metadata information about the columns along with the data types, and this is a free and open source format. So let's look at a data and let's understand how do you use the Apache Parquet format. So I have English Premier League results data from 93-94 season to 21-22 season sourced from Kaggle. So I have read the CSV file here and printed the data, few columns of the data, and we have 23 columns and 11,000 rows here, starting with the season, date, time, what is the home team, what is the away team, goals made by the home team and the away team, and the full-time result, which is here. So let's think that if we have 23 columns, but say I'm only interested in the top 4 or 5 columns, so how can I only read the required columns? So this is not possible using the CSV format, but say if I write this data using Parquet, then I can only read the whatever columns I require. So I am writing the data set into the Parquet format using write Parquet function, and then I am reading using read Parquet, and I have selected what are the columns I am of interest, so which is the season, date, time, what is the home team, away team, and the full-time result. So I can just look at those columns. So this is how the result looks like. Similarly, I can look at the schema. So what is the schema? So it tells us what is the column and what is the data type that is associated with each of these columns. Same thing, if I want to do it in Python, I use pd.read CSV to read this file, and then again this is how the shape of the data looks. And if I have to again write it into the Parquet, I will use tf.to Parquet, and then I will use the pd.read Parquet using pandas, and I can select the required columns, and this is how the data looks like. So one thing here is, if you want to read the data or write the Parquet data in R, you need Arrow package, and similarly in Python you need either PyArrow or fast Parquet. Let's look at data partitioning. So explicit data partitioning might make it faster for us to read the data. So in the above example, say we partition the data on season. So say we are always interested in any one particular season, and season is our most filtered column, right? So I can partition the Parquet on the season, and this is how I can do it by using a right data set and introducing a partitioning argument. And this is how the data changes. Instead of one file, now I have a list of files which correspond to each season. So what happens now is when I read any data, so I generally go for a particular season, so I can directly go and read that particular data corresponding the season. So this might make the whole workflow faster. So there are some trade-offs on how to partition the data. I will leave out the resources for you to refer. So then let's look at one of the important things, which is the benchmarking. So how much speed boost can I expect after moving to Parquet, or how much cost could be saved? So I'm referring here a study done by the Databricks, and they are comparing a 1 TB of data which is stored as CSV on an S3 bucket, and the query runtime here is 236 seconds. And for any query, as you know, that we need to scan the complete data, so the total amount of data scanned is slightly more than a TB, which is 1.15 TB, and the cost incurred is around $6 or 5.75 to be exact. Similarly, for a Parquet, if I have to store, this is 130 gigabytes. So Parquet is again a compression format as well. So the total data stored comes down drastically, and the query runs massively faster, which is under 7 seconds, and the total data scanned is a fraction of the 1.15 TB scanned, is just 2 gigabits, and the cost incurred is just cent, 1 cent. So this shows us how the Parquet format gives us advantage as our data set increases exponentially. So I want to introduce here the Apache Arrow format. So this format plays well with the Parquet. So Apache Arrow is in-memory tabular format for direct and efficient use of computation, and it supports complex data formats, and this is very much useful when you have a larger than memory data sets and you need to read or write these larger than memory data sets. And since this is an in-memory tabular format and plays well with Parquet, so there is no overhead in converting from one file format to other file format for the computation to happen. So I leave out the resources for Apache Arrow for you too. So let's look at game plan to improve your workflow speed. So the question is, should you abandon your CSVs right away and move to Parquet? So let's look at these questions, right? So you can stick with CSV if your workflow is limited only to getting data, and then it will be shared across with technical or business teams in a spreadsheet, and your data is generally flat and you just have a few thousands of rows or a few tens of columns. Then it's okay, you can stick with the CSV file. But if your data is very large, right, if your workflow requires a large amount of data to be read or write, then it's better if you move to Parquet. And say even if your workflow runs periodically to create a data set or update a data set, right, then also Parquet works better. And if your data set is too large to fit in memory, and CSVs are not good for it, then you should move to Parquet. So I'm leaving out some useful links, the copy of these slides and the websites for the Apache Arrow project, along with the bindings for R and Python. So you can just go through these for further information. Thank you.